I want you to take a second and think about your morning commute today,
Hmm.
or maybe just the last time you were in a really crowded airport terminal.
hmm
It feels like people are just everywhere, right? And we talk about overpopulation constantly. 8 billion of us. We feel like we're just bursting at the seams of the planet.
It definitely feels that way when you're stuck in traffic on the 405 or squeezing onto the tube in London. It really feels like humanity has conquered every single square inch of the globe.
Exactly. But then I started reading through the research for this deep dive, and I hit a statistic that honestly stopped me cold. It completely broke my brain for a minute.
I think I know the one you're talking about. Is it the 5% stat?
That's the one.
Yeah.
Despite there being 8 billion of us, despite our sprawling cities and massive highways, humans permanently occupy only about 5% of the Earth's surface.
It is wildly counterintuitive,
Isn't it insane? It implies that 95% of the planet is essentially a do-not-enter zone for permanent human settlement.
Right.
It changes the whole premise from we're running out of space to we are incredibly picky about where we park.
That is exactly the right framing. We aren't spreading out like butter on toast. We are clustering in very specific hives. And geographers actually have a technical term for that specific 5% slice where human life is viable and permanent.
Oh, right, the ecumene.
Yes, the ecumene.
It sounds like a sci-fi movie title.
It really does. It comes from the Greek oikoumene, meaning the inhabited world. And the mission for this deep dive is really to unpack the patterns of the ecumene.
To figure out the why.
Exactly. We want to move beyond just counting heads and understand why we are huddled in that specific 5%. Why there? And importantly, are we measuring overpopulation the right way?
Because when you look at the map, we aren't just scattered randomly like sprinkles on a cupcake. We are clumped.
Incredibly clumped. If you look at a global population density map, you'll see that nearly 2/3 of the entire human race is jammed into just 4 primary regions.
And those are East Asia, Southeast Asia, and Europe.
Correct. You could draw a circle around those 4 spots, basically ignore the entire rest of the map, the Americas, Africa, Australia, and you've already accounted for the vast majority of humanity.
Which begs the massive question of why there? Why not the middle of the Australian outback? Why not northern Canada or the Sahara? The research seems to break this down into 2 big buckets: physical factors, so the Earth itself, and human factors.
And you really have to start with the physical. At the end of the day, we are biological organisms. We have physiological limits. We can't just live anywhere.
This brings us to what I like to call the Goldilocks zone.
Essentially, yes. We are looking for the just right conditions. And the single biggest driver of where we live is latitude.
Latitude. So how far north or south we are from the equator.
Exactly. Humans have a profound bias toward what geographers call the mid-latitudes. We're talking about the band between 30 degrees and 60 degrees north and south of the equator.
Okay, let's unpack that a bit. Why that specific band? I mean, I love a tropical vacation. Why don't we settle the equator more densely?
It basically comes down to 2 things: soil and sickness. The mid-latitudes have distinct seasons. You get a summer and a winter.
Right.
Historically, that cycle is essential for the types of agriculture that sustain large civilizations, things like grains, wheat, corn.
You need the cycle for the crops to thrive.
Plus, the tropics, while lush and beautiful, often host aggressive disease vectors: malaria, dengue, yellow fever. Historically dense urban living in the tropics was incredibly difficult because the environment was actively trying to kill you.
So we want distinct seasons, but not extreme seasons.
Right, we avoid the extremes. If it's too hot, too cold, too wet, or too dry, population density plummets. We're looking for that moderation.
It seems obvious, but then you see these fascinating exceptions in the source material. There's this flip in Latin America that I found really cool.
Ah, the altitude exception. This is a classic exam question in geography.
So generally the rule is humans prefer lowlands. It's easier to build roads, easier to farm, easier to breathe.
Correct. Most of the world's great cities are at or near sea level.
But near the equator, people seemingly do the exact opposite. They head for the hills.
They do. Look at Mexico City. Look at Quito in Ecuador. Look at Bogota. These are massive population centers located at significant altitudes.
Right.
Why? Because if you are right on the equator, the lowlands are the too hot zone. They are humid, stifling, and prone to those tropical diseases we mentioned.
So to find the Goldilocks zone, they have to go up.
Exactly. They are trading altitude for latitude. By climbing the mountain, they enter a temperate climate that mimics the weather you'd find in France or Ohio. It's a brilliant adaptation.
That is really cool. It shows that we aren't just slaves to the map. We're looking for a specific atmospheric condition, and we'll climb a mountain to find it if we have to.
Precisely. Now, there is one other physical factor we have to mention, and it's arguably the most non-negotiable one.
Water.
You cannot have a civilization without it. If you overlay a population map with a map of major river systems and coastlines, they're almost identical.
It's not just about drinking water, though. I mean, obviously we need to drink, but it seemed like trade was the bigger driver in the reading.
Absolutely. Before trains and semi-trucks, water was the internet. It was the superhighway. It was the only way to move goods and information efficiently. If you lived in the arid interior of a continent, you weren't just thirsty, you were economically isolated, you were a dead end.
That explains why the coasts of South America and Australia are packed, but the middles are basically empty.
Exactly, we hug the edges.
Okay, so that's the hardware. The Earth offers us specific slots where we can live. Temperate, wet, flat, or high up if it's hot. But that doesn't explain everything. I mean, there are plenty of nice places that are relatively empty and some pretty miserable places that are packed.
And that's where the software comes in. The human factors. Culture, economics, and politics.
The economic piece seems the most straightforward. People follow the jobs.
They do. You can have a harsh environment, but if you discover oil or gold, or if a government decides to build a massive manufacturing hub, humans will override their biological preferences for a paycheck.
We see that with mining towns or oil rigs. People live in the Arctic Circle if the money is right.
Exactly. But there's also a concept called historical momentum that drives this. It's the idea that a city is big today simply because it was big yesterday.
It's inertia.
It is. Think about a place like New York City or London. Maybe they started there for a good geographic reason, like a deep harbor or a river crossing. But centuries later, even if shipping matters less, the infrastructure is there. The hospitals, the universities, the stock exchanges.
The gravity is already generated.
Right. It is incredibly difficult to move a population once it has set like concrete. The people stay because the services are there, and the services stay because the people are there. It's a feedback loop.
Unless you are the government.
Unless you are the government and you have a lot of authoritarian power. This is the political factor. Politics can act as a force multiplier for geography, or it can try to overwrite it completely.
The example in the dossier that really stood out was the Soviet Union.
Yes, the mid-20th century USSR. This is a classic case study. The Soviet government had a problem. They had massive resources, minerals, timber fuel located in Siberia.
Which is definitely not the Ecumene.
No, it is frozen, hostile, difficult terrain. Biologically, humans shouldn't be there in large numbers. But the state wanted those resources, so they created a policy to incentivize and often forcibly relocate populations to these areas. They built cities where nature never intended them to be.
It's a reminder that political will can essentially terraform a demographic map.
For a while, at least. It's worth noting that after the Soviet Union collapsed and that political pressure lifted, what happened?
People moved.
A lot of those populations drifted back to the warmer, easier climates. Historical momentum can only fight biology for so long.
Now, we've been zooming in and out a lot here, talking about global bands of latitude versus specific cities. The sources mention that this scale of analysis actually changes the answer to the why question.
This is a core concept in geography. If you ask why do people live here, the answer depends entirely on your zoom level. We call it being multiscalar.
Let's break that down for the listener, because I think we do this intuitively, but we don't realize we're doing it.
Okay, let's take a hypothetical listener. Let's say they live in Seattle. If we look at the global scale and ask why Seattle LX, the answer is physical geography. It's in the mid-latitudes, it's coastal, it has water access.
So globally, they are there because it's habitable.
Right. But if we zoom into the regional scale, why Seattle and not, say, a rural town in eastern Washington, now the answer shifts to economics. Boeing is there, Amazon is there, the port is there.
And if we zoom in even further to the local scale, why this specific neighborhood?
Now climate and global economics are irrelevant. Now you're looking at specific landforms like, I live here because the view is nice, or very local factors like this apartment is close to the subway station, or the school district is good.
So the why shifts from biology to economy to convenience the closer you get.
Precisely. You can't use a global explanation for a local pattern. You have to use the right lens.
Okay, I want to pivot to the math of this, because this is where the deep dive really earns its name. We've talked about where people are, that's distribution. But the sources spend a lot of time on density. And frankly, I used to think density was just people divided by land.
That is the common assumption. If you open a standard almanac, that's the number you see. But if you stop there, you miss the actual story of how humans live.
Right. The sources distinguish between 3 different types of density, and they tell completely different stories about a country's health and development.
They do. The one you just described, total people divided by total land, is called arithmetic density. It's the raw number.
But the experts seem to find it, I don't know, a bit lazy.
It's not that it's lazy, it's just a very blunt instrument. It assumes land is uniform. It treats a vertical cliff face the same as a fertile valley. It assumes you can live on every square inch of the country equally.
The Taiwan example really clarified this for me.
Yes, Taiwan is the perfect case study. If you look at Taiwan's arithmetic density, it looks incredibly crowded. The number is very high. You'd think the whole island is a mosh pit.
That's not.
No. The reality is that the interior of Taiwan is rugged, mountainous, and largely empty. It's beautiful, but you can't build a city there easily. So almost everyone is packed onto the western coastal plains.
So the average lies.
The average hides the pressure points. The experience density in the cities is way higher than the arithmetic density suggests.
So if we want to see the real pressure, especially regarding food and survival, we need the second metric.
Physiological density. This is the survival metric.
How do we calculate that?
You take the total population and divide it by the arable land.
Arable meaning farmable, dirt you can actually grow crops on.
Exactly. We are throwing out the mountains, the deserts, the parking lots. We are asking how many people have to be fed by each square kilometer of farmland.
And this number tells you something scary.
It measures vulnerability. If a country has a high physiological density, it means you have a massive number of people relying on a tiny patch of soil to keep them alive. Egypt is the classic example here.
Right. Egypt is huge on the map.
It's huge, but it's mostly desert. 95% of the population lives along the Nile River Valley. So their arithmetic density is low because they have lots of empty land, but their physiological density is astronomical. They are under immense pressure to produce food from that small strip of green.
That feels like a much more important number for a government to watch.
It is vital. It tells you about food security. But then there's the third metric, and I have to say this one felt backward to me when I first learned it. Agricultural density.
This one tripped me up too. This is total farmers divided by arable land.
Right, so we aren't counting the total population anymore. We are just counting the people working in the fields.
And the rule of thumb from the sources is that developed, wealthy countries have lower numbers here.
It is counterintuitive, right? You'd think more developed means more of everything, but in this case, a low number is a flex. It's a flex.
It's a technological flex. Think about it. If you have a low agricultural density, it means you have very few farmers working that land. But those few farmers are feeding millions of people. How are they doing that?
Giant tractors, combines, GPS.
Exactly. Capital and technology, they don't need a lot of bodies in the field because they have machines.
Whereas if you look at a developing nation,
you see high agricultural density. You might see hundreds of people working that same square kilometer. Why? Because they are likely subsistence farming. They're using hand tools. They don't have the capital for the machines, so they need the manpower.
So let me recap this to make sure I've got it. Arithmetic tells us how crowded the map looks. Physiological tells us how hard the land has to work to feed us. And agricultural tells us how much tech we're using to do the farming.
That is a perfect synthesis. And you can see how just saying density is high doesn't actually tell you the full story. You need to know which density. I want to wrap this up with a visualization from the end of the reading, the Texas thought experiment, because I think it perfectly bridges the gap between overpopulation and density.
I love this visualization. It's one of the best ways to deconstruct the fear of overpopulation.
So walk us through it. We're going to move the entire human race.
Okay, picture the entire human race. All 8 billion of us. Every person in China, India, Africa, Europe, the Americas. Now imagine we all decided to move into a single giant city.
Scenario A. We move to a city with the population density of Houston, Texas.
Now, Houston is not a dense city by global standards. It's sprawl. It's single-family homes, backyards, wide roads, strip malls. It's fairly spread out.
If all 8 billion of us lived at the density of Houston, how much space would we take up?
We would cover a massive portion of the United States. We'd be paving over the Midwest. It would be a colossal continent-spanning suburb.
Okay, now crank up the density. Scenario B. We all live like New Yorkers.
New York City. High-rises, apartments, subways, vertical living, roughly 29,000 people per square mile.
If all 8 billion of us lived at the density of New York City, how much space would we need?
The entire human race would fit inside the borders of the state of Texas.
The whole world.
In one state.
The whole world.
Yeah.
Every human on Earth inside Texas. That leaves Africa, Asia, Europe, South America, Australia, the rest of North America completely empty, restored to nature.
That is staggering. It really drives home the point that overpopulation isn't really about space. We aren't running out of physical room on the planet.
Exactly. It's about organization. It's about resource management. We aren't running out of land. We are running up against the limits of how we distribute resources within that land.
It takes us right back to the start, the ecumene. That 5%. We cluster because we need resources, but how we pack ourselves in determines our footprint.
And that footprint isn't static. That's the important thing to remember. The ecumene changes.
Which leads to the final question I wanted to ask you. We talked about how technology like tractors changes agricultural density.
Yeah.
But what about the bigger picture? That is the provocation I'd leave you with today. Throughout history, the ecumene has been defined by where can we grow food and where is the weather nice.
Right. Biology.
But look at what we are building now. We have air conditioning that makes the desert livable look at Dubai or Phoenix. We have desalination plants making fresh water from the ocean. We have vertical farming that doesn't need soil at all.
So the Goldilocks zone might be expanding.
Or becoming irrelevant. If technology allows us to ignore the physical constraints, if we can live comfortably in the Sahara or farm in the Arctic or build floating cities, does the ecumene explode? Do we finally start coloring in that other 95% of the map?
And what happens to the planet's ecosystems if we do spread out that far?
That is the billion-dollar question. Does spreading out save the planet, or does it destroy the last wild places? We don't know yet.
Something to think about the next time you are looking out a plane window at all that empty space. It might not stay empty forever.
Indeed.
Thanks for joining us for this deep dive. We'll see you on the next one.
Always a pleasure.